We know that kinetic energy final minus kinetic energy initial gives us the work. Now, in all cases, the force, net force that's acting on the object is always not constant. So, what happens if the force is variable? Let's try and derive the equation for the relation between work and energy. Now, let's take rate of change of kinetic energy and we get the rate of change equivalent. Then we can integrate it over the initial position to final position to get in case of a variable force. So rate of change of kinetic energy is given by with respect to time is d by dt of half mv square. Now when we differentiate this we get half times 2 mv dv by dt. These twos cancel out to give m, and dv by dt is rate of change of velocity is acceleration. So this gives us m times v times a. These m and a together, you can club it together as a product. This is force. Force is mass times acceleration. So this here equates to force times velocity. Now velocity is again rate of change of displacement. So force times dx by dt. Now these two are the rate of change, and this displacement rate of change is for a small distance. So let's integrate these two over the complete position. The left hand side it becomes kinetic energy initial to kinetic energy final, rate of kinetic energy equals from the initial position xi to the final position xf, f times dx by dt. Now we know that this over an entire distance gives the full displacement, and force times displacement is nothing but work. So again we get the rate of the change in kinetic energy from initial position to final position, which is nothing but kinetic energy final minus kinetic energy initial equals work, even if the variable force is there.